about some more characteristics of quadratics. And so just making sure you know these. Remember, vertex we talked about was like the turnaround point. The intercepts, we're going to focus heavily on the x-intercepts. Concave up and concave down aren't super huge things, but line of symmetry, axis of symmetry is something we've talked about, and I may abbreviate AOS for you. So the first thing I want you to be able to do is just to be able to find the zeros. And the zeros, if you remember when we took notes recently, have other names, roots and x-intercepts. And when I'm looking here, I can see that this one has 2. We also talked about this, I think. There could be 2 zeros, 1 0, or 0 zeros. Okay, so below you will actually see there's an example of all these. So this one has 2 zeros. If I ask you where they are, I want you to just look here. -1 0 and 2 0. Okay, these are the 2 roots or zeros or x-intercepts, the place where we cross the x-axis. Notice, for example, B, there aren't 2. It's just 1. This is called a double root. That's not really important, but it happens once right on the vertex. So this would be 1, 0. And then this last one, it never crosses. There are no roots, no zeros, no x-intercepts, whichever way you want to write it. So here's an example where there's none. So the first thing, can you look at a picture of a parabola and tell me where the zeros / x-intercepts / roots, where are they? Okay, be able to look and tell me. Okay, next from that, this is the same. Sorry, one more time. This one has 0. This one has 1, and it's at 3, 0. Okay, just right here. And this one doesn't cross at all. I want you to be able to find the axis of symmetry. So some of these will be super easy, right? We can just look. If I look right here, axis of symmetry is that line that makes it do the mirror fold, and it's right on the vertex. And so my vertex is 2, 0. My axis of symmetry is an equation. It's an x equals equation, and it follows this exactly. X equals 2. Okay, that one was easy. It was right on the vertex. Over here, I don't know the vertex. I could probably pick it out. No big deal. But just looking, I can tell this one is x equals 3. So the axis of symmetry is an x equals equation. So x equals equation, and it always follows the x of the vertex. My pen stopped working. Okay, I'm going to skip these. There is a formula that makes it easy to find the axis of symmetry if I don't give you a picture. So if you're looking at this, you don't have a picture, and I just gave you an equation, you can find the equation for the axis of symmetry by using the formula x equals, remember our axis of symmetry is an x equals equation, x equals -b over 2a. So a is 1, b is 3, and c is 4. I got these numbers from here. When there's no number, that's a 1. Okay, so x equals negative, my b is 3 over 2, my a is 1. This would be a good one to use when your vertex is not perfectly on a point. So you can see that -3/2 or -1.5 would be probably kind of hard for us to pick out. So that's where this equation comes in super handy. So let's try it again. A equals 2, B equals 1, C equals 3. So the equation for the axis of symmetry is -b over 2a. 1 over 2 times 2 would be -1/4. So this axis of symmetry would be at -1/4. We can use this to help us. how can we use it to help us? If I know the x-axis or the axis of symmetry, the x value, I can plug it in easily to find the y value. Okay, this picture, this one's not so hard. Shows me right here, -1, comma 2 is my, or 1, sorry, is my vertex. So it's going to be at x equals -1. But what happens if I don't have a picture? Okay, so I'm going to move this picture out of the way, actually, so I have more room to write. I'm going to use my formula, a equals 5, b equals -10, and c equals 3. I'm going to use my axis of symmetry formula first. X equals -10 over 2 times 5. So I'd get +10 over 10, which is 1. So my axis of symmetry would be x equals 1. If I know the x, I can plug it in to find the y. Y equals 5 times 1 squared minus 10 times 1 plus 3. 5 minus 10 plus 3 equals, and I think that you get -2. So my vertex, using the axis of symmetry, and then the original equation, so I got this from the AOS, and I got this from the original equation. I can use what I know about the axis of symmetry to find the whole vertex. Okay, so find the vertex of this graph. Again, I am going to use my axis of symmetry, -10, -b over 2a. -4 over 2 times 1. So +4 over 2 is +2. And I'm going to take that and plug it in. Y equals 2 squared minus 4 times 2 minus 10 minus 8 minus 10. And I think I get -14. So my vertex would be at the point 2, comma, -14, if I did it right. Okay, so that's it for today. There is a short assignment. I will try to make sure that you can submit it via Cami if you want. Remember, you can download the Schoology app and just take a picture of your notebook and turn it in too. All right, that's it.